gonna have more quizzes and tests, not necessarily just based on trig, but problems where you have to do the calculus and you have to apply finding either the inverse trig value or a trig value. And you don't really have time to make the whole unit circle. If you wanted to have a scratch piece of paper, it's not that bad though. I mean, you guys, some of you might want to do a triangle, some of you might memorize it, but it'll be fine. You'll see.
Hi.
Okay. So the next thing we need to look at are inverse trig functions. Inverse trig functions. Okay.
Hi, Preston.
Now,
Hi, Preston. Giving a call.
oh, that was very nice.
Thanks.
So the very last page of your notes had all the inverse trig. So the last 2 pages I copied the graphs. The very last page are the inverse functions. Now, remember, in order to have an inverse function, it has to pass the horizontal line test, right? So if I had the graph of sine, for example, so the graph of sine looks like, let's say here's y equals sine x. Just a real quick sketch, right? It doesn't pass the horizontal line, right? It doesn't pass the horizontal line test. So we have to restrict the domain, okay? So usually with sine, well not usually, but always, they're going to restrict it from negative pi over 2 to pi over 2. Or no, I'm sorry, from here to here. That's what I meant.
From where to where?
Here to here.
Oh yeah, and then cosine is the opposite way.
Right. So we can just look at this part. So from negative pi over 2 to pi over 2. Right, because now that will pass the horizontal line test, so when I find the inverse, that will actually pass the vertical line test. Yes?
So you mean instead of making it start from 0, they have it start like from
Right,
the
from
negative
negative
side so that it'll pass the horizontal line.
Right, so here, this range is from negative pi over 2 to pi over 2. Make sense?
Yeah.
Okay. And you can see on that last page, the domain and range are listed. Don't worry about the domain so much. I'm more focused on the range. What are the possible answers that we could get? So cosine,
Wouldn't it be the same thing?
what do you think for cosine?
But isn't it supposed to go to negative pi and pi because the period's 2 pi?
Right, but we don't want an entire period.
Okay.
If you include an entire period, it won't pass the
choose,
horizontal
like,
line test.
How much of the period?
You can't pick this is the thing. With the sine inverse graph, there could be another possible domain and range that would make it 1-to-1, but this is how these are defined. So it's only going to be between negative pi over 2 and pi over 2. For cosine, well, what about the cosine graph, Daniel?
0 to pi.
0 to pi. Because think about y equals cosine x, right?
Is it brackets?
What's that?
It's brackets, right? Yeah.
Right, so here, this is pi over 2 now. And it is brackets, yeah, it's brackets for sine and cosine. So if we look at just from 0 to pi, it's 1-to-1. If we did from negative pi over 2 to pi over 2, that wouldn't be 1-to-1. Do you see that? It wouldn't pass the horizontal line test then. So we just need to make sure that it does. What about tangent? Anybody remember tangent?
It's like.
Okay, so you remember what it looks like, but what about?
It's a
Oh, wait, the
period
Look at,
of
it's
one.
right there. You guys can actually look at your graph.
Negative pi over 2 to pi over 2.
Negative pi over 2 to pi over 2.
But
But not including, because there's asymptotes at the negative pi over 2 and pi over 2. So basically, you'll see in a minute when we do the examples, when I'm looking for an answer, I can only look in a certain location. With all of these inverse functions, there's only going to be one answer.
What do you mean one answer?
Okay, so sometimes we'll say, all right, where is sine equal to 1/2 on the unit circle? Well, sine is equal to 1/2 at 2 locations. Where is sine equal to 1/2? Here at pi over 6, and here at 5 pi over 6. Okay, so if I said sine of theta equals 1/2, and then theta is going to be between 0 and 2 pi, so I have those two answers. It's all in the notation. Do you see that? You have two answers because sine is positive in quadrant 1 and quadrant 2. Now, if I phrased it just a little different, I only have one answer. And that one answer is pi over 6. Why do I not include the 5 pi over 6?
Because the range for is sine versus negative pi over 2.
And what else did I just say about inverse functions? It has to pass the horizontal line test?
And it won't if you.
It won't, because if I had two answers, that's not possible. Then it wouldn't be a function.
So how do you know which one to choose? 'Cause
It's
negative-
all in the notation. It's all in how the problem is written. If I give you from 0 to 2 pi, then I'm gonna get two answers,
Yeah,
right?
yeah.
And if it's not, basically whenever you see the little -1, so the little -1 means there's one answer.
Miss Casey, if I did it, look.
Couldn't call the chili off. Oh no.
No. So
Okay, so secant, we're mainly going to focus on sine, cosine, tangent, but I want to make sure we're aware of secant. Secant is the reciprocal of cosine, right? So it's going to be,
Negative pi.
okay, so secant is the reciprocal,
of cosine.
again, look at you can look back, here. Secant is basically, I'm looking at the wrong one. Secant goes from 0 to pi, but you can't have it equal to pi over 2. Why? Because at pi over 2 it would be, there's an asymptote there. So it goes from 0 to pi, but y can't be equal to pi over 2. How about the next one? Cosecant. We'll think about what sine is. The reciprocal for sine. So it's going to be kind of the same idea as sine, but there's one place that's not possible. Do you know where the asymptote would be here?
0.
0. Okay.
Why?
Because sine is 0 at 0, so you would end up with 1 over 0, and that's not possible. And then the last one, cotangent. Cotangent is a little different because cotangent is cosine over sine. Where sine, cosine over sine we want from 0 to pi. And again, you can just look at the graphs too for those, because otherwise it wouldn't be 1 to 1, because the asymptotes are at 0 and pi for cotangent. Good? Okay. Keep that in mind for the next page. Okay, so now you can kind of use a combination of the unit circle, but also those ranges that we just filled in. Because all of these have one answer. You see how all of them have the little -1 exponent? Right? One answer. And it has to be in that range that we defined.
So the first one you want it in degrees?
Okay, all of these need to be radians. So inverse trig functions, and always in calculus, we're going to work in radians. Now, obviously you can use your calculator, but the goal is not to use your calculator, to think about the unit circle. So what we're asking ourselves is, where is sine equal to 1? So where is the y coordinate equal to 1? Pi over 2. You need to think, okay, so let's,
Because the sine is the y. Oh, yeah. And the next, you're right.
good?
That's slow. Okay.
Question? Yes, Matthew?
So what I did, I don't know if I was doing something, but I like sine both sides to cancel that.
well, you don't have an equation. You could do sine of both sides, but then you would have to introduce an angle theta. But you're still asking yourself at what angle. I mean, if it's easier, if that's how you learned or whatever, but, I mean, let's see if it works for the others. How's that? Okay, cosine of root 2 over 2.
Wait, don't say it out loud.
Cosine inverse.
Let everyone
5/4.
think.
Okay, everybody think about,
No, I'm still thinking.
he's still thinking. He's not sure about it.
Oh,
Isn't it?
Okay,
Wait, I
ready?
need 30 more
1,
seconds.
2,
Wait,
3.
wait.
Pi
5/4,
over
hold
4.
on.
Wait,
Pi-
but it could be any of them. Right?
Wait a minute.
Oh, no. There's two in. Oh, no.
There's only one place from 0
Oh,
to
you're right.
pi
Yeah.
where cosine is root 2 over 2. Remember, we have to think about the restricted range, the restricted answers. We have to.
Enough.
Okay, don't call it out. Think about it.
Okay, don't say
And
it.
don't say it. Tangent inverse of 0. Hold on. Think
Wait,
about it.
wait,
Write
wait.
it down.
Break it down now.
Wait, please don't say anything.
87. One hot this time.
Wait, don't say it.
Are you ready?
Okay, okay.
Okay, ready? 1, 2, 3,
Pi
say it.
two.
Pi, yes.
Pi over
No, no,
2.
2
Pi
pi,
over
2
two.
pi, 2
Two
pi,
pi,
2
two
pi, 2
2 pi.
pi.
Zero. Pi
Two.
over.
Oh, yeah. It's
Okay,
it's
so-
zero. It's 2.
Hold on.
No, it's 0. Pi
2
over 2.
pi.
Look at the tangent. Okay, just a minute. Look at tangent inverse. My only possible answers could be between negative pi over 2 and pi over 2. Now you
Pi
said
over
2
two.
pi.
Pi over 2.
No, because
No, it's definitely
It's
pi.
0. Okay.
Oh,
I was
so-
right.
Wait,
Yes, 2 pi, 2 pi,
Wait,
0.
0 2 pi, that don't make any sense. Yeah, but you can't put 2 pi because that's.
No, because of us.
Huh?
tan is sine over cos, right?
Okay. You can consider,
Oh, you're right.
you could consider tangent inverse as the same as sine inverse over cosine inverse, right? So sine inverse of 0 would be 0, cosine inverse of 0 would be 1. So you have 0 over 1, which still ends up being 0. So you could rewrite it that way.
That was 0 in between negative pi over 2 and pi over 2.
Has to be between, yeah, the answer for tangent has to be between negative pi over 2 and pi over 2.
Wait, where is 0, like, according to that? Like, right in the middle. Wait, but it, I was going the wrong
That way.
How do you
Okay.
know you have to go that way?
So when you're talking about, like, here in this next one, we have sine. Basically for sine, we look at from negative pi over 2, here's 0, here's pi over 2. So we ignore the other two quadrants because it's not going to be 1 to 1 there. So we're going to ask ourselves, where is sine equal to negative 1/2? Well, it has to be quadrant 4. Okay, so negative 1/2 would be negative pi
over 6.
pi over 6.
Oh my god. But you said it had to be in quadrant 4.
Has to be in quadrant 4. Okay. So a lot of students will want to write 11 pi over 6, which would be a correct answer if I said I was looking for answers between 0 and 2 pi. But because of the little negative 1, we have to write it as negative pi over 6. Okay? It's a little tricky, but
We'll get the hang of it.
we'll get the hang of it, I hope. Okay, cosine inverse of negative root 3 over 2.
What?
Okay,
Don't say
now-
it out loud.
Don't say it out
Let's
loud.
all
Write it
take, let's
down.
all take 45 seconds to think.
I'll just look. Let's write it down. I'll see if you guys got it.
Wait, 20 minutes. Cosine,
Thank
0 and pi.
Oh my God, this is so good.
Oh my goodness, negative, what?
I got it!
No, no, it's just-
No, I didn't.
Wait, no.
I didn't catch it. No, I didn't.
Are we still thinking?
Oh, it's negative. Oh,
But
right.
it's negative.
Oh, wait. This is what I got.
No, but these are the only ones we got. Yeah, he's right. So it's.
Yes.
Is this right?
Yes.
Oh, yeah.
So which one is this? 11 pi over 6.
I'm just killing it.
Almost. Too much.
Am I right?
Yes. Let me see.
Can you send
Yes.
How about now?
Can you spoil it?
Wait, how about now?
Maya, go first. You deserve it.
Okay, Maya.
5 pi over 6.
5 pi over 6.
Woo! Oh, what?
Okay.
I knew it.
The first thing we need to consider is that the answer can only be between 0 and pi, because that was the range. So if it's negative, right, it's gotta be over here. Well,
Wait, so how do you
Why?
know, why does negative, oh, it's on the left side, but.
got it?
It's on top and not on bottom.
Because of that range I was telling you about,
Oh.
excludes the two bottom quadrants.
What's the range, 0 and pi? Zero and pi is the range.
What's that? Oh, 0 and pi is cosine, yeah.
I don't
Okay.
know. I don't
No.
understand that that's the range. Like why it's only
Why?
180. Yeah.
Anybody? Why do we have that particular range?
Okay, because you need a one-to-one function, and if you have two answers, it's not possible to have two answers and still have it be a one-to-one function.
Okay, we call these inverse functions, which means there can only be one value. So we had to restrict the domain of the original function so that it was one-to-one. Remember, we did that previously with like a parabola and you had two sides and we had to say, oh, we can only take the one side. It's kind of like that, but with trig functions, we have to say we have a beginning and an ending point. And for the different trig functions, it's going to be different because obviously they're one-to-one at different intervals. So it's almost like just memorize that that's where, memorize those range values.
Are we gonna be testing all
So
three
the most-
problems tomorrow?
Well, I'm going to give you problems like this. So you just have to apply it.
Yeah.
Wait, who can do it?
Wait, what's tomorrow?
Miss
I don't know
Casey.
about that.
But we're basically in AP.
Like
Yeah.
the memorizing, so sine has the two quadrants under like 1 and 4, and then cos has 1 and 2.
Correct.
But does tan have 1 and 4 also, or 1 and 2?
1 and 4.
1 and 4. So
Okay,
I'm just
so
gonna memorize
sine-
it like that.
Just
Yeah.
memorize it like that. You really only need to know those three. I may give you a secant or a
No,
but
don't
it's.
do it.
You wouldn't do that, I know you.
I won't give you anything too crazy.
Madeline wouldn't
It's
want
pretty,
you to.
it's pretty straightforward.
Yeah, she wants to give us all pretty hard.
That's true.
Stars.
Okay.
So, okay, so
Can I just clarify really quick?
All right, you want to write down an answer for F? Cotangent inverse of 1.
Oh,
Pi over root.
I don't know, but I would love to write it down.
Yeah. Did you guys take the last one?
Like, I don't know, because you have to memorize.
Can I, let me continue, and then, we have a whole big trig review worksheet I was planning on spending time with you
Can I
guys.
help with number A of example 2?
Okay, cotangent, where is tangent equal to 1?
What? What is it? Negative pi over
Because
4.
cotangent is just the reciprocal. So sometimes it helps.
Pi over 2?
No, 0.
It's pi over 2.
Just pi over 2.
Okay, we got some work to do, it'll be okay.
Pi over 4, sorry, pi over 4.
Okay,
Alright,
guys,
I got
So
it.
mean, I'm like, God.
remember, tangent is the ratio of sine over cosine, and cotangent is the ratio of cosine over sine. So if it's equal to 1, we're basically saying where is sine and cosine equal to each other? At 45-degree angles, right?
Uh-huh.
So what if I change that answer to a -1? Well, it would still be a 45-degree angle or a pi over 4. It would just be in a different quadrant. Okay. Let's continue because I feel like the more
We did like a
examples we
bunch
do,
of these.
I have a whole bunch on a bunch of review. Okay, the next one.
It's pi over 4 and 3 pi over 2.
No, these are calculator problems.
Wait, can I just to clarify, so sine and tangent are 1 and 4, and
I thought I
cos
did it.
is 1 and 2.
Too bad.
Yes, that's correct.
That was right.
You do need your calculator for the next two.
Should we put them out in degrees or radians?
Radians, always radians.
Okay.
All right, do you have your calculators ready?
I do.
Ready, Matthew? Is this how you?
It'll be fun.
Isn't this kind of like what I said I did before? Like, but instead of doing
Oh.
we sign in this one side.
Yeah, that's right. Yeah. Okay. All right, this one's a little bit different because this one, I have a domain of the entire unit circle basically.
So it's not gonna be.
So it's not just gonna be one answer, it could be more, it could be two answers. Well, it will be two answers. So let's just talk about, notice it says sign is equal to 0.7. That's a positive number. So imagine on the unit circle here, where is sign positive? It's gonna be quadrant 1 and quadrant 2, right? Because sign is the y coordinate, so we want just the top part. We basically ignore the bottom. Okay, Maya, you have a question?
I just had like, can I guess on how to do it?
Sure.
Change it. Okay, because it's 0.7 and pi over 2 is like 1 point something, could you assume that it's in the first quadrant?
Yes. Okay, on your calculators, so we're gonna, notice I'm gonna use the sign inverse to find what x is equal to, but there's gonna be more than one answer there. Basically what this gives us is a reference angle. It's not always gonna be the reference angle, it's a little confusing, but go ahead and just plug that into your calculator and we go to 3 decimal places. 775. Okay, that 0.775 is somewhere here in the first quadrant. Do you agree with that? You could, if you're not sure, change it to radians. Or sorry, change it to degrees. So, or you can just put your calculator in degrees, but I could just do 0.775 times 180 over pi. So it's about 44 degrees.
Oh, so it's a 45
Okay.
degree angle.
It's not exactly a 45-degree angle.
Is
So
this- is
that's
there-
why we don't want to write pi over 4. We want to write the decimal approximation because this is not root 2 over 2 on this side. Okay, so here we just said it's about 44 degrees. It just helps for those of you that need to see it a little more visually. I want to find the corresponding angle in quadrant 2.
Add 90.
Yeah, I was gonna say add 90 to 0.775.
Add 100.
Try again.
180 minus 44.
180 minus 44, or
2 pi, or pi minus.
right, this is pi. So to find this, I'm going to take pi minus 0.775. So this is basically one answer.
Oh, this isn't that bad.
It's not that
Do you
bad.
have more problems like this on the quiz? Cause this seems just
There's like one like this on the quiz, I think.
make 2 and
So
one extra.
we want 2.
Yeah.
No, speak for you.
I already
Or
made
put
it.
you on her quiz.
Yep. Give me extra.
That could be on the
2.3.
6, 7.
She's on quiz track.
Oh, you know what? I want to change. Can we change this one also?
Say Carlos Danger. Carlos Danger.
Take away the negative of infinity to infinity. I want to change it to 0 to 2 pi. Just I would rather have you guys have practice with that. I'm not going to have you do any from negative infinity to infinity anyway. Okay, so tangent of x is equal to negative 2.
Okay, no one see this.
Now, think about that for a minute. Tangent is negative. So when I'm picturing the unit circle, what 2 locations, what 2 quadrants will tangent be negative? So
Third. No, second and third.
second,
Second and
fourth.
oh yeah.
My circle isn't too nice here. Hold on.
Huh?
Okay, so here and here.
Oh.
Right, because tangent's positive in the first quadrant. Remember, all students take, so in the third quadrant, tangent's positive. We want negative.
Yeah.
Okay, plug that into your calculator. What do we get?
Negative 1.107. Is that the one in the fourth quadrant?
Okay, now there's a little bit of a problem with that answer. Can you look at the domain that I gave you? What's the domain that I gave you, or I told you to change it to?
X is between 0 and 2 pi.
Oh, is negative 1.107 between 0 and 2 pi?
No.
No, so could you find the corresponding location that would be?
Yeah.
Add 2.
Add 2 pi would be one way. Sorry, Matthew. So if I took this and I added 2 pi, that's going to give me, oops, this location right here. Right?
I got 5.176.
What about in the second one?
Ah, so we still have to figure out the second quadrant.
We do.
there's a couple ways we could get that. This is tangent, so the period is pi.
We do pi minus 1.17.
What do you think? There's a couple ways we could get that answer in the second quadrant. That's one way. Matthew?
Couldn't we subtract pi or divide it by 2?
You could subtract pi. That would be fine.
Wait, I don't know how would you
Okay.
get to it? 'Cause you
So
wouldn't-
remember, this was, so we said it was this quadrant. This was -1, sorry.
How do you know that's -1.17?
You put it in the calculator.
Oh, it changed the
So you know from Algebra 2 and from pre-calculus, if you get an angle, you can always add 2 pi and it's gonna get it's gonna get a coterminal angle is what we call it. Just like going around the unit circle again. You can add 4 pi, you get another location. But how do we get this one? So there's a number of ways we could go about. Do you remember reference angles? Sort of. The reference angle is the angle that it makes with the x-axis. So, for example, when I talk about like 5 pi over 6 has a 30-degree reference angle,
Oh.
because it makes a 30-degree angle with the x-axis.
Oh, yeah.
Pi over 4, 3 pi over 4, 5 pi over 4, they have a reference angle of 45 degrees, because they make a 45-degree angle with the x-axis. So what would this reference angle be? It would be 1.107.
Uh-huh.
These two angles here and here have to be the same.
So
Do you agree with that? They have to be the same distance away from the x-axis.
Yeah.
So you could do pi minus 1.107, or you could take this answer and subtract pi. Because like here you have, this is equivalent to 5.176. If I went backwards pi units, I'd get this one.
How do you know to subtract pi? How do you know to use pi instead of like something else?
You always work with pi. Okay, don't work with pi over 2, 3 pi over 2. You always work with pi or 2 pi because you're working with the x-axis. And what angles are here?
So
This
pi is
angle
2
is
pi.
pi and this is 2 pi.
So pi would get you halfway around, and if you added 2 pi, you'd be back where you started.
Right, exactly. Pi would get you halfway around and then 2 pi would get you go around the whole time.
Wait, so why are you adding 2 pi? That's what I don't understand.
So-
it's less than 2.
Because I need to make sure that what's 2 pi approximately? What's pi? 3.14?
Yeah.
So 2 pi would be 6.28. So all of my answers need to be between 0 and 6.28.
Oh, it can't be negative 1.
Can't be negative,
So
because
that's why
it
you added
would-
2 pi.
Exactly. So what, did somebody figure out what the other answer would be?
Yeah, it's 2.034.
So it has to be between
Oh.
0 and 6 point whatever.
Right. Okay, that was tough. Was that tough?
Is that gonna be on the quiz?
I can handle
I
it.
think I got
I
it.
think the first part
Can
was
we take
long.
the sneak peek?
We're all
Or
ready,
give us a
ready,
couple
go.
hints?
I mean, or give us a practice.
Yeah,
in
yeah.
case